Hello, this is D58 Microprocessor Microcontroller Lab. Experiment number 4, sorting of numbers. The aim of this experiment is to realize that how to arrange an array of byte numbers in ascending order for 8086, and we'll be find out maximum and minimum numbers present in the array. The logic behind this is, let's say you are going to arrange the byte data, but 8086 is a 16-bit processor. You're supposed to arrange it in the arrange it word data, but to start with you can think of byte data to be arranged. Assume you have 5 datas, so you need to arrange it in ascending order. How are you going to arrange it? You need to compare it. Take this register. Actually, you need to understand that those datas are in the memory, external memory, and obviously the first memory before starting to the array, the first memory says what is the array size, which will be 05. Together this 05 is an array, right? So what you're going to do is I need to compare this data and this data. In order to compare it, bring this data into the processor. Let's say I store it in some register AL and store this 56 in BL, because the 8-bit data now, so that is what I am using, 8-bit register. And now the data, these two data which are in memory coming to the processor, which is stored, which are stored in AL and BL respectively. Then I am going to compare it. By comparing this, I can arrange it back. Then I will write it back to the memory itself. Okay, this is quite straightforward and things very clear. But coming to this, how many comparison you are going to do? I will be comparing this and this, but when you want to compare it, you have to bring it into the processor register. But anyway, you have to compare this and this. So first compare one, then after that the data will be arranged, right? Skipped or arranged such a way that it is in ascending order. First compare, and I have to compare this and this, thereafter this and this, and thereafter this and this. How many compare? It is compare 2, compare 3 and compare 4. So look at very clearly, the array size is about 5, number of comparison to be made is 4, that is array size minus 1 time. That is very clear. Now let's say I am going to arrange it in by comparing one by one. So how I am going to arrange it? By comparing this and this, I will understand that 56 is lesser. So since this is ascending order, so I keep 56 in top of that and 71. Yeah, now 71 is in this memory. So this going out, right? Again I write back this data to this memory. Assume that this first memory is 56 now after first compare, and second memory is 71. Now I take second memory and third memory, I am comparing it, this and this. Obviously 71 is greater, less than that 72, then I no need to swap it. So no need to have swap, leave it. So the swap is not required, failed. Now this is third data. Third data is compared with the fourth one. Now you are comparing this and this such way that the 48 is less than 72, right? So then I swap it. So 48 and 72. You understand? The same data, the data, modified data is arranged in the same memory itself. You no need to have separate memory for storing the started data, right? Yeah. Now this is the fourth data, and along with fifth data I will compare this and this. Obviously this is greater and this is less than that, and I need to swap it. How I am going to swap it? 37 comes up. 37 and 72. Good. So this is the first iteration we call. One iteration is over. But even all comparison on first iteration is over, but data are not arranged ascending order effectively. Still 37 is here, right? But what happened in the first iteration? It is concluded that the last one is a maximum among this array. That is good, right? And anyway, so now this one no need to be compared. You need to compare for the remaining top data. Now how many compare you need to have? 1, 2, 3. You can save the time, right? So that's it. So now in second iteration you need to go for again what? Already you have n minus 1, here n minus 2. That comparison is over. That is sufficient. So what I do now? Now go for second iteration. This is iteration 2. Iteration 2, right? Iteration 2, and I compare the things one by one. Compare this and this. Obviously 56 is less than 71, so no need to swap it. Compare this and this. Obviously 48 is, so 56 is here, 48 is less, so keep it on top. 71. So I'm swapping it. Okay, fine. This is their data. The third data and fourth data is being compared. 37. Obviously, 37 is less than that. So what I need to do? 71. I keep it down, and 37. I think you will understand that, right? 72 is not at all adjusted or compared. That's it. So during second iteration, what happened? So I just clear all the remaining things, otherwise it will confuse you. So within the same memory, of course, the first is not disturbed, right? This is saying that array size. So look at this: data 1, data 2, data 3, and data 4 and data 5. So only 2 iteration is over, right? Now again one more iteration I have to go back. I have to go. So what is iteration number 3? So I'm going to compare this and this, that's it. Because how many iteration is over, then you can left the remaining data, right? So only 2 iterations to be done. Upon on third iteration, upon comparing this and this, 48 is less, right? So there is 48 and 56, right? Then 37 comes. Now 56 and 37 is being compared. Obviously 56 is greater, and this is being arranged. What happened? This is 37 and 56. As it's 71, 72 and all being stored here. So after third iteration, the memory being modified with this data. I think you will understand it very clearly. Right? Yeah, just wait for it. Erasing it. So on third iteration, yes, good. So iteration third is over. Upon third iteration, you have the data being arranged, but still you look at very clearly, still there is no ascending order, right? But the lowest data is all arranged ascending order properly, but in middle you have 37. So you have to go for one more iteration. So that is fourth iteration. On fourth iteration, what will happen? This fellow is going up and that is coming down. That you know it, right? So the array size is 05, 37 goes up, and 48. And 48, 56 compared, so there is no swap, and 56 is here. And 71 and 72. That's it. So this is over. So you need to go for n minus 1 compare for, you need to do n minus 1 time of iteration. Understand? If array size is 5, then you need to go for 4 iteration. If array size is 3, then of course you have to go for 2, so on so forth. Correct. The array size will say how many iteration you have to go. Per iteration, how many compare that you have to do and all. You can look at the logic and you can do it. Right. Coming to the program, this is how they have written the program. Yeah, you understand that. You imagine that the data being arranged from 8000 to 8000 1009. Of course, 8000 will have the array size. Now the effective data, byte data are stored from 1001 to 1009. So here you will write the data. Before execution, you will have the count 10 and you have the data. After execution, the data being modified, but whereas the count size will not be modified and remaining data will be modified. Arranged in ascending order. That is your experiment. So I need to initialize the address 8000 AX on so forth. DL count. The DL register and CL register for counting. DL register for number of iteration and CL register for number of compare. So count minus 1. This count, how it takes count, that is missing, right? Yeah, the processor is supposed to bring count value for this. How it brings count value? So you have to initialize SI register that is not being initialized. We write it the code right now. MOV SI, 1000H.